Hi there, folks. This is the practice chapter 12 test, and as always, I am the amazing Mr. Jansen. So here we go. If I take a look at this first one, it's asking me to find the next four terms in the arithmetic sequence. And arithmetic means I'm adding the same thing each time. And in this particular case, the thing that I'm adding really looks like I'm subtracting a 4, which means I'm adding a -4 each time. So I'm adding a -4 each time. So I just continue to add the -4. That's going to give me a +9, then a +5, then a +1, and then a -3. Okay, so those are my next four terms. If I take a look at the next one, it says find the 13th term of the sequence. Since I'm given a sub 1 is 7, and I'm giving a d value here, so since they give me a d value, I know that this is arithmetic. So this tells me that it's arithmetic. So now I'm going to find the 13th term. My arithmetic sequence formula is this: a sub n equals a sub 1 plus n minus 1 times d. And I just plug in what I know. I know the first term is the 7. I know that I'm looking for the 13th term, so n is 13. Remember, n is the number of the term. My d value is given here. It's a 3. And really now I'm finding a sub 13. And now I just have to plug this into my calculator. And when I do that for this one, it looks like it gives me a 43. That's it. If I take a look at the next one, it says to find the four arithmetic means between -6 and +9. So I've got a -6. 4 blank spaces, that's what the arithmetic means are. So I'm missing 4 terms. And I just want to fill in these blanks. In order to fill in these blanks, I need the d value. And really what's given here, I'm given the first term, which is a sub 1. I'm given the last term, that means that this is a sub n. And I can see how many terms I have. There's 1, 2, 3, 4, 5, and 6. So now I'm using my arithmetic formula. The a sub n equals a sub 1 plus n minus 1 times d. And I plug in what I know. I know the first term is the -6. I know that I have 6 terms. That's my n value. I know that a sub n, the last term over here, is 9. D is the thing I'm looking for. Now I just need to solve for d. So I've got 9 equals a -6 plus 5d. I'm going to go ahead and add the 6 to each side. And then divide by the 5. And I find out that d equals 3. But that doesn't quite answer the question. I actually have to add this 3 each time. So if I do the -6 plus 3 is going to give me, fill these in a different color, it's going to give me a -3, plus 3 gives me a 0, plus 3 gives me a 3, plus 3 gives me a 6. Add it one more time, it gives me the 9. Now I know that my answers are correct. And again, the thing it's asking for is what goes in these blank spaces. Okay? The next one, it asks me to find the sum. And right away, it also gives me a d value. So that tells me which sum formula I'm using. I'm using my arithmetic sum, which is s sub n equals n over 2 times a sub 1 plus a sub n. And I plug in what I know. I know that I'm looking for the first 20 terms, so s sub 20 equals 20 over 2. That was my n value. I know that a sub 1 is the 7. A sub n is the last term, and that's the thing that I'm missing here. But I do have a d value, which means I have to use my other arithmetic formula. I have to use the a sub n equals a sub 1 plus n minus 1 times d. And I have to find that a sub n value. So I'm looking for a sub 20 this time. A sub 1 is the 7. N once again is the 20. D, it was given to me before. I didn't need it before, and now I do, is the 11. Okay? And now once again, I'm just going to plug this into my calculator. And it looks like that gives me a 216. So now I have my a sub n. Now I have another job for my calculator. I plug that in. I do a little bit of adding and multiplying. It looks like I get 2,230 for my sum. Okay? For this one, it said to find the sum of the arithmetic series. So once again, arithmetic means I'm using this formula. The s sub n equals n over 2 times a sub 1 plus a sub n. And I plug in what I know. I know a sub 1. I know the first term is the 13. I know the last term. See, this was the first term. The last term is the -25. The thing I don't know is the n value. So I need another formula. I'm going to go to my other formula, which is the a sub n equals a sub 1 plus n minus 1 times d. Yeah, I just start plugging in what I know into the proper formula. If I'm missing something, I go to my other formula, I know that a sub n is the negative 25, a sub 1 is the 13, n is the thing I'm looking for. The d value I can easily identify by just identifying the pattern. How do I get from one term to the next term? Looks like I'm subtracting 2 or adding a negative 2. So that's my d value. And I'm just going to solve this. I'm going to go ahead and subtract the 13 from each side. When I do that, it gives me a negative 38. Here I can distribute that negative 2. So I'm distributing the negative 2. That gives me a negative 2n plus 2. And now I'm going to finish solving this thing. I subtract the 2 from each side. That gives me a negative 40. I divide by the negative 2. And I find out that n equals 20. All right. I'm not done yet. I got to take it back over here. So I plug the 20 into its place. Now I know I'm looking for the sum of the first 20 terms. And now it's just a matter of plugging it into my calculator. So it looks like it gives me a negative 120. That's it. That's the sum. If I look at the next one, I've got sigma notation here. Remember, this is my starting value. This is my stopping value. So I start by plugging a 1 in. So I'm plugging a 1 in right here for n. When I plug a 1 in here, I have 2 times 1, which is 2, minus the 9, which is a negative 7. And then I plug a 2 in. When I plug a 2 into this thing, it gives me a negative 5. And then I plug a 3 in. Gives me a negative 3. I plug a 4 in, I get a negative 1. I plug a 5 in, and it gives me a positive 1. And now sigma tells me that I need to add all these values together. So I plug a 1 in, then a 2, then a 3, then a 4, then a 5. That's where I stop, starting value, stopping value, and then I add all these together. It looks like it gives me a negative 15. Okay? So again, I add all these together after I plug each of these values in. So I plug the values in, I add it up, and I'm done. Okay? If I look at the next one, it says to find the next 2 terms. As I look at the pattern, I'm clearly not adding the same thing each time. In this case, I'm multiplying by something each time. And it looks like the thing I'm multiplying by is 2/5. When I do 10 times a 2/5, it gives me a 4. When I do 4 times the 2/5, it gives me an 8/5. If I multiply the 8/5 by 2/5, it gives me a 16 over 25. And then if I multiply the 16 over 25 by 2/5, it gives me a 32 over 125. And that's it. Those are my next 2 terms. That's what it was asking for. Okay? If we're unsure about what we're multiplying by, just work backwards. Just ask yourself this question. 10 times something, I'll call it x, equals 4. What does that something have to be? Well, I just have to solve for x. 10 times something equals the next term, and it happens to be the 4 over 10, which is 2/5. Okay, that's the thing I'm multiplying by each time. You can always work backwards. Okay. This one asked me to find the 5th term, and notice right away that it gives me an r value here. Since it gives me an r value, that tells me that this is a geometric series. So I'm doing a sub n equals a sub 1 times r to the n minus 1. And I just plug in what I know. I know that a sub 1 is the 1458. I know that the r value is 2/3. And it's raised to the n minus 1. N this time is 5, so I do 5 minus 1. And now really this just becomes a job for my calculator. So I'm doing the 2/3 raised to the 4th power. I should at least be able to do that part in my head. And then multiply it by the 1458. Okay? And when I plug all this in, being very careful as I punch this into my calculator, I get 288, and that's it. All right? If I look at the next one, it says to find the 4 geometric means this time. So I start with a 7. I have 4 blank spaces in here, and then the 224. I'm looking for geometric means this time, which means I need the r value. Since I need the r value this time, again, I still have the same pieces of information I had before the a sub 1. This is a sub n, the last term. I know that there are 1, 2, 3, 4, 5, 6 terms. So now I just use my formula a sub n. Again, I'm using this formula, a sub n equals a sub 1 times r to the n minus 1. A sub n is the 224. A sub 1 is the 7. R is the thing I'm looking for. N this time is a 6. And now I'm just solving this thing. I divide each side by the 7. So that gives me a 32 equals r to the 5th power. In order to solve for r, take the 5th root of each side. So I find out that r equals a 2. Okay? But then I actually have to fill in the blanks here. I take the 7 times 2 gives me a 14, times 2 gives me a 28. times 2 gives me a 56, times 2 gives me a 112, and then times 2 does give me the 224. So now I know that I've found the correct R value. I know that I've filled in the blanks correctly. Okay? This one, it says to find the sum of the geometric series to 6 terms. Again, it's geometric, so I'm doing S sub n equals a sub 1 times 1 minus r to the n all over 1 minus r. That's the formula that I'm using. I want the 6th term, so it's s sub 6 equals a sub 1, which is the 1/9, times 1 minus r. This time the thing I'm multiplying by appears to be a 3, so I'm multiplying by a 3 each time. That's my r value. N is a 6, because I'm finding to this first 6 terms, over 1 minus r, which once again is the 3. Okay? And once again, this just becomes a job for my calculator here. When I do this, I personally like to take order of operations into my own hands. And I would probably do 3 to the 6th power, then 1 minus that, then times the 1/9, and then divided by the -2. And when I do that, it looks like it gives me 40 and 4/9. That's what it would be as a mixed number. If you wanted to leave this as an improper fraction, that would be fine. That would be a 364 over 9. That would be the other option. The one thing I don't want is this thing as a decimal. And really, if you plug this into your calculator, it should spit this out as a decimal. It'll spit out a 40.4 repeating forever. And you should know that 4 repeating forever is 4/9, so you should immediately write it as 40 and 4/9. Okay? If I look at the next one, once again, sigma notation, I've got my starting value is the 1, my stopping value is a 4. So I'm going to plug the 1 in. When I plug the 1 in, it gives me a 6. And then I plug the 2 in. When I plug the 2 in, it gives me a 12. Then I plug the 3 in, that gives me a 24. And then I plug a 4 in, that gives me a 48. Sigma tells me that I need to add these together. So that's what that notation means. It says, hey, start with a 1, work your way up to 4, add all these values together. And when we do this, the 48 plus the 24 plus the 12 plus the 6, looks like it gives me a 90. And that's it. If I look at number 12, it says to find a sub 1 given s sub n equals 105, r equals -2, and n equals 6. So I'm using my s sub n formula. Since it gives me an r value, I know that I'm using this particular formula, a sub 1, the 1 minus r raised to the n all over 1 minus r. And I'm just plugging in what I know here. I know that the s sub n is the 105. I know that a sub 1 this time, oh, that's the thing I'm looking for, so I'm just going to leave that as a sub 1. I've got 1 minus r, which happens to be the -2, raised to the n, which is 6, all over 1 minus the -2. And that's my r value. And you just have to be pretty careful here, especially right here with these signs, the negative and the negative. The temptation is to make that adding the opposite, but we have to follow order of operations. So when I do this, I have to do that -2 raised to the 6th power first. So I have a sub 1. Right here I have 1 minus -2 to the 6th power. That 6th power takes care of this negative, and that ends up giving me a positive value here. So I end up with 1 minus a positive 64 now. Okay? All over. Down here we can actually do this. That's adding the opposite. So that's going to give me a 3. So now I'm going to solve this. I've got 105 equals a sub 1 times, that's going to be a -63. So I get a -63 times a sub 1 all over 3. I'm just going to keep on simplifying this side. -63 divided by 3 gives me a -21. And now I just divide each side by this -21. Now I'm at the point where I'm going to solve. And really, this is just testing you on, can I take this formula and manipulate the equation a little bit? And when I do the 105 divided by the -21, it gives me a -5. And that's it. So my a sub 1 is a -5 this time. Okay?